Today we are going to continue the previous class session. Today we are doing session 2. Whereas in the first session we explained what do you mean by basic gates, what do you mean by derived gates, and the basic gates and or not, how to write the symbol as well as truth table. Today we want to explain in the derived class which are the derived gates we have. On that how to write the symbol as well as truth table, regarding that you will study. Whereas in basic gates you will get and or not are the basic gates. Under derived gates we have NOR gate, NAND gate, XOR gate, and the fourth one is XNOR gate. These are the four derived gates: NOR gate, NAND gate, XOR gate, XNOR gate. Why it is called it as derived gates? Because it is derived from the basic gates. With the help of basic gates it is derived. That's why it is called as derived gates. First, one by one we will explain. First one I am going to explain NOR gate. NOR gate is a combination of NOT gate as well as OR gate. Whereas for OR gate, just for OR gate, we are using symbol reverse C shape we used to write. Then we will connect this. Then maximum we required 2 inputs or minimum 2 inputs, maximum more than 2 inputs also we can take. Whereas output is A plus B we used to write. For NOT gate, one line and then one triangle, at the end one circle and then line. This is a NOT gate. This is a symbol for we are using for OR as well as NOT. Whereas NOR gate is a combination of NOT gate as well as OR gate. Then how to write the symbol as well as truth table, that I am going to explain. For example, NOR gate. If you have two variables, for example A and B. A and B. Here's the true input variable. Once again here you have to write C shape only. C shape. Then connect this. At the end you have to write one circle and then line. For OR gate how we are writing? 2 lines, then C shape, then we will connect. We are not writing any circle here for OR gate. Whereas for NOR gate you have to write one circle here and then the output. Then what is the output here we get? A plus B whole bar. Up to here it is A plus B, but here once it is crossed with a circle then it is a negation, NOT gate. It is a combination of NOT gate as well as OR gate. If you want you can like this way. Otherwise you can write A and B become the input, reverse C shape. Then connect this. Here output become A plus B. Then take down NOT symbol. Triangle, at the end one circle and then line. Once it is passed from here, then output become A plus B whole bar. If you want you can write like this pattern as well as this pattern. Both are correct when it is 2 variable. For 3 variables how to write? See A, B, C. Minimum 3 inputs. A, B, C. Then here one circle, not circle, reverse C shape. Then connect this, at the end write down one circle and then line. What is the output? A plus B plus C whole bar. A plus B plus C whole bar. This is the symbol for 3 variables. And this is the symbol for 2 variable, especially for NOR gate. Then how to write the this is a symbol we are using. Now next how to write the truth table, that I am going to explaining you. When it is 2 variables, maximum 2 inputs here A and B. If you have confusion how to write A plus B whole bar, then you can use one more output here. First write down A plus B. Then it will be easy to find out A plus B. First find out A plus B, then A plus B whole bar. Like that also you can write. When you have 2 variables, then 2 zeros, 2 1. 0 1 0 1 pattern. Next, you know how to write A plus B, because if you have plus operator, if any one of the input is 1, the output you can write 1. If all the inputs are 0, then only the output become 0. Now 0 plus 0, whereas in AND operation dot multiplication you have to keep, whereas in plus idu ಅಥವಾ ಆರ್ ಕನ್ನಡದಲ್ಲಿ ಹೇಳುವಾಗ ಇದು ಅಥವಾ ಅಂತ ಹೇಳೋದಕ್ಕೆ ಆರ್ ಅಂತ ಹೇಳ್ತೀವಿ. Now 0 plus 0 the output become here 0 only. 0 plus 1 output become 1. 1 plus 0 1. 1 plus 1, 1. It is A plus B output. Now just reverse that, just negate that. Whatever output here we have got, just reverse that. 0 here we have, then output is 1. Here we have 1, 0, 1, 0, 1, 0. When we get 1, when all the inputs are 0, then only the output become 1 here. If you want, you can write this directly. Otherwise, first find out A plus B, then just negate A plus B whole part. Then you will get the same result. This is the truth table for 2 variable. This is the symbol for 2 variable for NOR gate. This is the truth table for 2 variable in NOR gate. For 3 variables, how to write for 3 variables? Same pattern. In the previous case, how we written the same pattern. A, B, C. Then take down one more output here. First A, B, C. For us to represent the output, first find out A plus B plus C. Then just negate that. Reverse of whatever output here we have got, just reverse, negate it. Then A plus B plus C whole part. When you have 3 variables, write down 4 times 0. 1, 2, 3, 4. Then next write down 4 times 1. 1, 2, 3, 4. Next write down 2 times 0. 0, 0, 1, 1, 0, 0, 1, 1. Next alternative 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Now find out A plus B plus C. Then you can easily find out A plus B plus C whole part. 0 plus 0 plus 0, the output become 0 here because all the inputs are 0. Then next 0 plus 0 plus 1. Minimum 1 time if you have 1, then output become 1. Here 1, here also we have 1, 1. Here also we have 1, output is also 1. Here also 1 time we have, then also output is 1. Here also 1. Because here 2 times we have 1 once again. All the inputs are 1, 1. Now just reverse it. Here 1, 0. Here we have 0, that's why here we are written 1. Now here 1, 0, 0, 0, 0, 0, 0, 0. From this we can say that when all the inputs are 0, only on that case the output become 1, otherwise it becomes 0. This is the truth table for 3 variable, especially in NOR gate. And it's see symbol for 2 variables, symbol for 3 variables. Truth table for 2 variables, truth table for 3 variables in NOR gate. Next, we are going to explain regarding NAND gate, how to write the symbol as well as truth table for NAND gate. That also once again we will explain. Whereas already I told you, these are called it as derived gates because it is derived with the help of basic gates. That's why it is called it as derived gates. Now one by one we will explain. Now NAND gate. NAND gate is a combination of NOT gate and AND gate. That's why it is called as derived gate. Combination of NOT gate and AND gate. Whereas for AND gate we are writing the symbol in the format of D shape. Minimum 2 inputs were required. If A and B are the input, the output become A dot B for AND. Now for NAND, how to write? See, for 2 variables, consider A and B become the input variables. Here write down D shape. At the end, write down one circle and then one line. Then what is the output? A dot B whole bar. If you want, you can write in another way also. If A and B are the input, first write down D AND operation. Here we will get A dot B. Then negate it. Not operation. Then output become A dot B whole bar. There is a symbol for 2 variables. If you want, you can write like this way. Otherwise, like this way also. Then also you will get full marks. Then if you have 3 variables, A, B, C. If you have 3 variables, then how to write? See, A, B, C. These are the 3 variables. Once again, write down D shape here. Then at the end, one circle and then one single line. Then what is the output? A dot B dot C whole bar. This is the symbol for 2 variable in NAND gate. And this is the symbol for 3 variables in NAND gate. Next, I am going to explain how to write the truth table for 2 variables as well as for 3 variables. Then first I am to explain for two variables. See, consider A, B. Then here first I will find A dot B. Then easy for you to find A dot B whole bar. Then A dot B whole bar. Now write down 2 0 2 1 0 1 0 1. Now A dot B. Here when the output is 1, when all the inputs are 1, then only the output becomes 1, otherwise it is 0. Otherwise in the blind method in your mind you can keep multiplication operation. When all the inputs are 1, then only the output becomes 1. 0 into 0, the output becomes 0. 0 into 1, the output becomes 0. 1 into 0, the output becomes 0. 1 into 1, multiplication operation in the same format. 1 into 1, the output becomes 1. See, 1 into 0, generally any number multiplied with 0 is 0 only. In the same way here, 1 into 0, 0. 0 into 1, 0. Here 1 into 1, the output becomes 1. Whereas A dot B whole bar, whatever A dot B here we have got, just reverse that. Then here 0 we have, then 1. 0 here we have 1. 0 we have 1. Then here 0. When all the inputs are 1, then only the output becomes 0. Otherwise the output becomes 1 here. For two variable, especially for NAND gate. Next, for three variable, how to write the truth table for three variables? In the same pattern, take down A, B and then C. Output first find out A dot B dot C. A dot B dot C. Then finally just find out A dot B dot C whole bar. If you have three variables, then write down first 4 times 0, 4 times 1. 1, 2, 3, 4. 4 times 0 here I written. Next 4 times 1. 1, 2, 3, 4 times 1. Next alternative 2 times 0, 2 times 1. 2 times 0, 2 times 1. Next 0, 1, 0, 1, 0, 1, 0, 1. Now A dot B dot C. Here it is nothing but multiplication operation. When all the inputs are 1, then only the output becomes 1. 0 into 0 into 0, 0. Here 0 into we have, that's why 0. Here also we have 0, 0. Here also we have 0, 0. Here also we have 0, that's why output 0. Here also we have 0, 0. Here also we have 0, 0. When all the inputs are 1, the output becomes 1. In the case of A dot B dot C. Now A dot B dot C whole bar. Whatever A dot B dot C here, just reverse that. Then here 0 we have, then 1, 1, 1, 1, 1, 1, 1, 0. It means that here you will get 0 when all the inputs are 1 here. This is nothing but the symbol as well as truth table for NAND gate. Next we will explain regarding XOR gate. In XOR gate, odd number of 1 we have, then the output becomes 1. Otherwise it is 0. And here it takes the help of OR gate and then it is constructed. That's why it is called it as XOR gate. Now that we'll explain once again here. See, to represent this XOR gate, minimum we required 2 input except NOT gate. For remaining all we required minimum 2 input. See, A and B. A and B. Here C shape only you have to write. One more C shape you have to write, then write on the output. Here to represent the output A plus B, for plus you have to write circle. To represent XOR gate, the output is A plus B, for plus you have to write circle. This is the symbol for 2 variable in XOR gate. Now for 3 variable, how to write A, B, then C. Reverse C shape. Once again reverse C shape, then connect it. Then what is the output? A plus B plus C. For plus you have to write circle. This is the output for XOR gate. And here this is the symbol for 2 variable. This is the symbol for 3 variable, especially for XOR gate. Now you studied how to write the symbol. Now how to write the truth table. For example, 2 variable if you have, then A, B. This is the input variable. The output here we use, right? A plus B whole bar we are writing. 2 0 2 1 0 1 0 1. Whereas XOR gate, if you get odd number of times 1, then the output become 1. Andre 1 ಅನ್ನೋದು odd number of times ಇದ್ರೆ 1 ಅಂತ ಬರಿಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ 0 ಅಂತ ಬರಿಬೇಕು. ಇಲ್ಲಿ 0 0. ಹಾಗಂದ್ರೆ 1 ಅನ್ನೋದು ಎಷ್ಟು ಟೈಮ್ ಇದೆ? 0 times. 0 times it is nothing but even number of times. Then output become here 0. Now here how many times 1 we have? Only one time. Only one time we have 1. Whether 1 ಅನ್ನೋದು even or odd, it is odd. Then output become 1. See here, how many times 1 we have? Only one time. Only one time means it is odd. Then 1. Here 1, how many times here we have? 2 times. 2 times is nothing but even, then it is 0 here. From this you come to know that the output is 1 only when odd number of ones if there, then the output become 1, otherwise it is 0. ಹಾಗಂದ್ರೆ 1 ಅನ್ನೋದನ್ನ ನೀವು ಕೌಂಟ್ ಮಾಡಬೇಕು. ಕೌಂಟ್ ಮಾಡುವಾಗ odd number of times ಬಂದ್ರೆ 1 ಬರಿಬೇಕು, even number of times ಬಂದ್ರೆ ಅದನ್ನ 0 ಅಂತ ಬರಿಬೇಕು. Now for 3 variables, how to write? Same pattern. In the previous case how we have written, the same pattern we will write. For 3 variables, A, B, C. Here the output A plus B plus C. For plus it write circle. Now 4 times 0, 4 times 1. 4 times 0 and then 4 times 1. Now 2 times 0, 2 times 1. 2 times 0, 2 times 1. 0 1 0 1 0 1 0 1. Now find out how many times here we have 1. No, we don't have any 1. Then it means that it is even. Then output becomes 0. How many times 1 here we have? Only one time. Then it is 1. Just count how many times 1 we have. Here only one time. One time is odd. Here how many times we have? 2 times. 2 times 1 we have. If you have 2 times, then it is even. Then here you write 0. Whereas here only one time we have, that's why 1. Here 2 times we have 0. Here also 1. Once again 2 times we have 0. Here how many times we have 1? 3 times. 3 times means it is odd only. Then output becomes 1. Now is it clear? This is the symbol for 2 variable in XOR gate. This is the symbol for 3 variables in XOR gate. Now this is the truth table for 2 variable. This is the truth table for 3 variable. In the exam they would ask, write the truth table for XOR gate for 3 variables. Like that also in the exam they would ask. Just keep it in your mind. Odd number of times you have to count. ಒಂದು ಅನ್ನೋದು ಎಷ್ಟು ಟೈಮ್ ಇದೆ ಅನ್ನೋದನ್ನ ಕೌಂಟ್ ಮಾಡಬೇಕು. ಆಡ್ ನಂಬರ್ ಆಫ್ ಟೈಮ್ಸ್ ಇದ್ರೆ 1 ಅಂತ ಬರಿಬೇಕು. ಇಫ್ ಇಟ್ ಇಸ್ ಈವನ್, ಜಸ್ಟ್ ರಿವರ್ಸ್ ದಟ್ 0 ಅಂತ ಬರಿಬೇಕು. ನೌ ದ ಲಾಸ್ಟ್ ಒನ್ ಇಸ್ XNOR gate. Just in the previous case only I am going to explain, I am going to just replace XNOR gate. Here this is XOR gate. Only here you have to make the changes. Here you have to write one circle, then one line. The output become A plus B. For plus here written circle whole bar. Now is it clear? XNOR, just I am just replacing them. For you it will be very easy to remember how to write. If you want you can write like this way, otherwise A dot B. For dot you write circle. Like this also you can write. See, this is a symbol for 2 variable, especially for XNOR gate. Now for 3 variables how to write? In the same pattern, here write down 0. Here write down 0. For this A plus B plus C. For plus circle at the end whole bar. If you want you can write the output like this pattern. Otherwise A dot B dot C. For dot write down circle. Whichever way you want you can write here. Now is it clear? This is the symbol for 2 variable in XNOR gate. This is the symbol for 3 variable in XNOR gate. Now how to write the truth table for 2 variables, that I am going to explain. For 2 variable as well as for 3 variables. Now here what is the output? If you want you can write A plus B for plus circle, then one line you can write. Otherwise, if you want, you can write A dot B for dot, write on circle. Whichever way you want, you can write. Whereas, in XOR gate, odd number of times we are counted, whereas for XNOR, even number of 1 you have to count and then write down the 1. Just see. First time 1, how many times we have? 0 times. 0 is nothing but even. Even ಅನ್ನುವಾಗ 1 ಅಂತ ಬರೀತೀವಿ. Now here how many times we have 1? 1 time. Odd. Then odd ಇದ್ರೆ ಇಲ್ಲಿ ನಾವು ಬರಿಬಾರ್ದು. Now here the output become 1 or 0. See, first case we have 0 times, that's why here we written 1. Now here odd number of times. Odd number idre baribardu, even idre matra baribeku. Here 0, 1 time we have, it is not even. Here also we have odd, that's why 0. When you have even number of times, then write down 1 here. Now is it clear? Andre mind alli itkobeku, XOR gate ge 1 ಅನ್ನೋದು odd number of times ಇರಬೇಕು. XNOR ಗೆ 1 ಅನ್ನೋದು even number of times ಇರಬೇಕು. See, here 2 times here we have, that's why here we written. Here we don't have any 1, it is nothing but even only, that's why here we written 1. Now for this one, when you want to write the truth table for 3 variables, A dot B dot C, for dot write on circle. See the first case, 0 0 0 1, how many times here we have? We don't have any number of times, it is nothing but even, that's why it is 1. Next, odd